Hey, so we're looking at angle relationships between parallel lines and transversals. This is the instructional video for the different types of angles that we've got, and you can see the setups here of a bunch of things. So we've got some parallel lines and some transversals, just some vocabulary, right? We know that these lines are parallel because of the parallel symbols, and we can pick them up there. We can pick them up over here on the second question. Down here on this question, we can see them over here. And on this question, we see them up here. And then we've got these transversals. Transversal is really just a fancy name for a line that cuts between two parallels. So on this line, it's right over here. You can see it. A little trickier on this one, if you look for the two parallels, the transversal's right there. And on we go. So a couple of little things. The first one is, we'll start off with this one right here. And we're looking here at angle A. And we know that that angle right over there corresponds to this angle A down here, and we need to know what is it, how do we know, or what is the name of this angle relationship. So the way to think about this is if you take a look at the parallel lines, you're either going to be inside the parallel lines, interior, or you're going to be outside the parallel lines, exterior. And in this case, we can see that angle A is outside of those two parallel lines. So this is going to be an exterior angle, or these are exterior angles. The question is then, are they on the same side or on opposite sides of the transversal? And if you look at this A and you bring it up, you can see it would be like on the opposite side. Actually, it would be over here, sorry. If I slid this one up, it would match up right there, right? If I took this angle, this line here, and I slide it right up to there, you can see that angle A, to keep its position, would be right down in there, which would make it a vertically opposite, which is another type that we don't see here right now, but you can see that this angle and this angle are the same. And so we call this one an alternate exterior. Why alternate? Because it's on alternate sides of the transversal and outside of the parallel lines. Now on this one over here, we don't have quite the same situation, or at least the orientation looks a little different. So I'm just going to take a second. I'll show you a little trick that sometimes helps us visualize. I'm going to extend that parallel line, and I'm going to extend that parallel line, and then I'm going to extend the transversal. So you can really see now how this one looks a lot like this one. In this case, the two angles, angle B, which is there and there, are inside the parallel lines, but they're still on opposite sides of that transversal. So these are going to be alternate interiors. And again, a really good way of visualizing that is if I bring the line up, and you can really kind of see how they match up. This triangle, I know it doesn't look like one of these, but this triangle really is one of these. Just same thing, I'm going to extend those lines so you can get a really good look at it. And now you can see that same shape happening, right? I don't really need this side over here. There's no comparison on this setup up here, but these are called corresponding angles. And you can tell they're corresponding because, same deal, if I take my ruler, imagine that line and slide it up, you can see how that one angle would lay right over the top of the other. They're on the same side of the transversal, but one's inside and one's outside of the parallel lines. It's not like over here where both are inside or both are outside of the parallel lines. One is in and one is out, but they're on the same side as the transversal. We call that corresponding. And in this case, we already know because I've mentioned it, but I'm going to extend those parallel lines here and here again, and then extend that transversal. And now you can kind of see the two parallels with the big transversal, just like I had two parallels with the big transversal here or here or here. And in this case, where these two angles cross, whether right opposite each other, wherever you get that X shape, those are called vertically opposite. And in each of the four cases, the big thing to remember is that the angles are the same. They'll be the same number of degrees, whether they're alternate exterior, alternate interior, corresponding, or vertically opposite. That's our instructional on different angle relationships.